We've already organized our information, and now we have to do our first calculation. My recommendation to you is to do this calculation using the dimensional analysis setup. There are a lot of conversions to do, and dimensional analysis is the easiest way to keep track of all of these conversions. What we are asked for is the minimum milliliter per hour rate. It is also the initial pump setting. So when I look through this entire problem, way back at the beginning I had the order, and it is 2 to 20 micrograms per kilogram per minute. So I'm going to start with the minimum, which is the 2. The first label, the micrograms, goes in the numerator, and the second two labels, both the kilograms and the per minute, go in the denominator. Now I have to start working with my labels to get to my goal, and my goal is to get to milliliters per hour. It does not matter which order you do the conversions in. So the first thing I'm going to do is take care of the time. So I know that 60 minutes goes on the top in my numerator, and that is the same as 1 hour. And so that cancels the minutes. Next, I want to deal with the kilograms. So up here I have the patient's weight of 155 pounds, and previously we had divided this by 2.2, and we found their weight in kilograms to be 70.5 kilograms. So kilograms is in the denominator, so I want to put 70.5 kilograms in the numerator, and I simply put that over 1. Because that's equal to my 1 patient. But I don't want to write patient there because I want to get to milliliters per hour specific to this patient. And so that allows me to cancel kilograms. Now way back, second week of the course, we talked about the conversions, and one of the ones that I listed was the micrograms to milligrams. So we have from that handout of lecture 2 that there are 1,000 micrograms in 1 milligrams. And this time I put micrograms in the denominator to cancel with the numerator. Finally, I am ready to go to milliliters per hour. And so I'm going to do this based on the dosage strength. And we had already identified this, that the dosage strength is 500 milligrams, and that goes in the denominator so that milligrams cancels. And those 500 milligrams are in 250 milliliters. So my only remaining labels are hours in the denominator, milliliters in the numerator, which is exactly what I wanted. Now we've done these problems before, so in your calculator you'll take 2 times 60 times 70.5 times 250, and then you'll divide by 1,000, and then divide by 500. And going through that process, you'll get an answer of 4.23 milliliters per hour. It's very important to write down this unrounded number because we're going to need it later. But our actual final answer is supposed to be rounded off to tenths, and so we round this to 4.2 milliliters per hour.